Watch Mr. Wizard. That's what all the kids in the neighborhood call him because he shows them the magic and mystery of science in everyday living.
Hi, Mr. Wizard.
Oh, hi, Betty Sue.
Oh, there's that spiral again that we had on the candle.
Yeah, this time I've got it sitting over a lamp, and you know what makes it go around? Do you remember?
Well, doesn't it have something to do with the heat?
That's right. I'm using it this time to explain, or help explain, what makes the wind blow. Can you tell me what makes the wind blow?
Well, does it have something to do with heat?
Right, it has something to do with heat, too. So you should be able to explain that later, and at the same time, well, let's leave it on.
Okay.
At the same time, explain what makes the wind blow. First of all, before we do that, I want to explain that today we're going to investigate various aspects of weather.
Weather.
What is weather?
Weather?
Yeah.
Well, a day could be hot or cold, sunny or cloudy, rainy, snowy, or clear.
Yeah.
That's it.
Okay. Now, this is what we're going to find out. How come some days are hotter than others, or colder than others? How come some days, it rains, some days it doesn't? Let's take the first one, for instance. You said hot and cold. Why are some days very hot and other days very cold?
Well, because some days the sun is hotter than on others.
Okay, that at least it feels like it, doesn't it? For instance, summer and winter.
Summer and winter. Yeah.
Okay. Here is a diagram. This represents the sun.
Yes.
See? This represents the earth. So what does this circle represent?
A year.
That's a year, because the earth goes around the sun once in a year. Notice, however, at one place it's 95 million miles from the sun, and in another place it's only 91 million miles from the sun. Now, one of these is summer and one is winter. Which do you think is which?
Well, this one, where the Earth is only 91 million miles away from the sun, would be summer because the Earth is closer to the sun.
Makes sense. Then you'd say that this one is winter.
Yes.
Oh. It's very logical, but it's entirely incorrect.
It is?
Yeah. In spite of the fact that the Earth is farthest away, this is summer. And notice now that the Earth's axis is tipped towards the sun in the summer. It's tipped away from the sun in the winter.
Oh, I see, yes.
Now, here is going to be our Earth. So it's tipped like this towards the sun in the summer and away from the sun in what I say is the winter. Now let's see if we can see why this makes summer and winter. Come on over here, because we're going to use this lamp as the sun. See?
This?
This lamp, which I have pointing down here on the desk, so that when I turn it on, I can get a little spot of light down there.
Oh, there, I see.
Now that spot of light represents the heat of the sun.
The heat of the sun.
The brighter the spot is, the hotter the sun would be, right?
And that's pretty bright.
And that's pretty bright. Notice I've cut a circle of cardboard around that just fits that, see? So that we can now use this as a standard.
I see.
And I also have cut another piece off here with a mark on it, see? So that shows how high or how far away the light is from the table. See? Now notice that this time it points straight down.
Yes.
Because what I'm going to do now is to turn the lamp like this.
You're tilting it up.
And tilting it up like that. Now I'll get the same piece of cardboard.
It's the same distance.
See, so get it adjusted so it's the same distance now. Now you take that standard that we had before and you put it down there in the middle of that spot. What happens?
Well, the other spot, this spot,
Yeah.
is much longer than this one was.
Much bigger. So what's going to happen to the amount of heat here?
Well, it won't be as hot because it's not quite as bright as the other spot was.
Well, the point is that the same amount of light is now spread over a larger area, isn't it? So
Yes.
therefore, as far as the amount of heat within this circle, it's going to be less than when the sun was straight down. Okay, now keep that in mind, because now, well, here, let's get this diagram. Because I want you to realize now, because we're going to take that light and put it on this Earth. Okay? First place now, I said that in summer the Earth was pointed which way? Toward the sun. In the winter,
it's pointed away
from the sun. Okay, now keep that in mind, because now you hold that Earth. I'm going to turn this lamp up, put this little thing on it so we can make a smaller spot. Okay. Now, this is the sun.
Right.
In the summer, which way is the Earth pointed?
Toward the sun.
It's pointed toward the sun. You see that little round circle there?
Yes.
Well, let's say that's about where we are.
Oh, okay.
So now it's summer, right?
Right.
Notice how that's a nice little round spot, just like the one we had on the
Just
desk?
directly on this little
Right.
spot.
See? Now you see, there's a lot of heat concentrated there.
Yes.
Okay, now this really doesn't happen because the sun moves, but I'm going to now switch this around this way because in the wintertime what's happening?
Oh.
It's away from the sun, isn't it?
Yes. And the rays from this are slanted.
See how they're slanted? They're very weak, aren't they?
And they're not quite as bright,
right.
and it's over a larger area.
Yes. So now, in spite of the fact that there's 3 million miles difference between the distance between the sun and the Earth in summer and winter, which is summer and which is winter?
Well, when the Earth is farthest away from the sun, it's summer, because the axis of the Earth is facing towards the sun.
Towards the sun, that's right. Notice the North Pole, by the way.
Yes, well, wherever the sun happens to hit, it's always
slanted up at the North Pole, isn't it?
That's probably why it's so cold up there,
Yeah.
because they never get direct sunlight.
Right. And how about the sun down here?
Oh, and the South Pole, same thing.
Now, haven't you noticed some everyday examples of the fact that where is the sun at noon in summer?
Well, it sort of looks the same place all the time.
Well, it's up in the sky.
Yeah.
How about its height?
Well, come to think of it, it's directly overhead, because whenever I lay down to take a sun bath, it's right in my eyes.
Now, when you take a sun bath in the winter, what happens?
Well, I've never done it, to tell you the truth.
Why not?
Well, because it's cold out.
Because what happens to the rays of the sun?
Well, they're sort of over on the horizon.
The sun is over on the horizon, so the rays are slanted, and therefore it's cool. Okay, now that's the major difference between the hot summer and the cold winter. However, when you go out in summer and you say it's hot out, you're not talking about the ground, which is what we were talking about here.
No,
right?
you're talking about the air.
How does the air get heated?
Well, by the sun.
Well, except that the air is transparent and the sun's rays go right through the air.
Oh.
We have another problem.
Yeah.
Which I think maybe you can solve for me when you see these two things over here. See what those two things are?
They're thermometers.
They're thermometers, that's right. Notice there are two, one marked
land, and the other is marked sea.
Okay. Now, I put this card over the top because I didn't want the lights in the room to hit these two. Now, wait, let me turn it this way. This one in the front here is marked sea, and notice what it is like?
It's silver.
It's shiny, isn't
Yes.
it? This one in the back is the one that's marked land, and what
It's
color?
black.
And that's black, that's right, okay. So the one marked land is black.
And the one marked sea is silvery.
Okay, now here is a sun lamp. I'm going to turn the sun lamp on, and the sun is now going to hit the black and the silver one, or the land and the sea one. What's going to happen now?
Well, I think that since the tube or something
Yes.
on the land one is black, and since the land does absorb heat, that this is going to absorb the heat, the land.
Okay, and what's going to happen to the sea one then?
Well, since the sea thermometer is silver,
Yes.
and water does reflect sunlight,
Yes.
that the light of the lamp, when it hits the one of the sea, is going to reflect right off.
So it'd get hotter or cooler? Or
Well,
shouldn't be as hot?
The sea will be less than the
Okay,
land.
let's turn on the sun now and see. Now, can you read what it says? What did they start at about? They're both about
82.
80 or so, right?
Mm-hmm.
Okay. Is one beginning to move?
Oh, yes, the land one is moving quite
Already?
rapidly.
Right.
Yes,
It's now
up
about
to
it, right?
86.
Okay, how about the sea?
It's at 82. And this one's climbing, and now it's almost at 90. Now
Almost
it's
at 90, and what's happening to the sea one?
The sea one is still 82.
So you see how the land now is heating up much faster, isn't it?
Yes, much faster. Now it's 92, and the other one is still... No, now it's 84.
Now it's
The other
beginning to
one-
move just a little bit. Well, you see how the land is beginning to move, get much, much hotter, much more quickly.
Yes, much more quickly.
Now, so what is there the most of on the Earth? Ocean or land?
Ocean.
Yeah, about 4/5 of the land surface, or of the Earth's surface, is land. So this means what's going to happen to the air sitting directly above the land?
Directly above the land.
Yes.
It should get heated by the land because
Right.
it's warm.
Right. And what about the air that's sitting over the oceans?
Well, it should be cool.
It shouldn't get as hot, should it?
Not quite as hot.
Okay, now we have some of the air being heated up and some of the air not being heated up so much.
Yes.
Yeah. Now, what's going to happen to the air that's heated up over the land?
Well, it's going to expand.
Yes.
And let's see, if the cold air moves because it stays low, it
Why?
contracts. Why does it stay low?
Yeah.
Because it's heavier and the gravity pulls down.
Okay, so what's that going to do to the warm air?
Well, it's going to push the warm air up.
Yes. Most people say hot air rises.
Yes, it does, doesn't it?
Yes, but it's pushed up by the
Really?
cold air, right? By gravity pulling down the cold air. Well, then you should be able to explain without any difficulty at all what makes that little paper go around now, shouldn't you?
Yeah, I know. I think I know.
Okay.
Well, the light bulb in here gives off heat.
Okay.
And the cold air from underneath the lamp pushes the heat of...
First of all, what does the air around the light bulb do when it gets hot?
It expands.
It expands.
It
Okay.
tries to expand.
Okay.
And so the cold air is going to push the warm air from the light bulb up. And it's going to make this spiral go around.
Now, wait a minute. First of all, let's stop for just a minute. Because I want you to see underneath here is a piece of cardboard, see?
With little holes in it.
With a little hole in it, and a thumbtack in the middle, and the stem of the thumbtack going into this piece of wood. See, so you can make one of these at home very easily. Now, then you take a piece of paper, sort of cardboard, and you cut it into a circle first. See? And then you begin cutting here until you make a spiral. You cut in and in and further and further until you end up about this far. Then you cut little, what are those called?
Points, sir.
Points? All right. There's a word in sewing that they use, but I've forgotten what it is. Anyway, you put a thimble in there. See? Now you pick the thimble up.
Okay.
See, and that makes
there's
it
the
spread out
spiral.
here. Okay. Now, up on the top of this rod, I put a needle, because it has a nice sharp point. So here, now give me the needle, or the
Spiral. There.
the spiral with the... So now when we put the thimble over there, it'll go around on that little tiny point of the needle and make a very good bearing.
There it goes already.
Now what happens when the heat comes out of these holes?
Well, it touches various parts of the spiral and forces it to go around this way.
It's going to push against that spiral, and because the spiral is a spiral form going up, it makes the thing turn around. Okay, now notice how it stopped now?
Yes.
One of the reasons for this is because the air coming up here, the hot air moving up, is really not very powerful, not very strong. So sometimes air currents in the air, when we walk, we make the air move, you see. Sometimes they hit here and we'll stop it. But then when it quiets down again, then it'll start moving. Well, now that's what makes the whirligig go around, but when you came in, I said that this would help you explain what makes the wind blow. Now, in order for you to explain what makes the wind blow, I want you to look what I have right here. Here's an aquarium.
Oh, look at it.
And here,
Ice cubes.
ice cubes. Let's put those down here on this side.
There's a little Eskimo there.
See the little Eskimo sitting down there? So we'll put the ice like that.
Oh, that'd be the North Pole. The
So
Arctic.
this is the Arctic. Notice there's a little girl over here, a Hawaiian girl, see? Okay. Now there's also a girl here in the middle.
Oh, I see.
Now I'll put this on top. Remember this magic smoke stuff, that
Yes.
called titanium tetrachloride. It just smokes when you get it in the air. I want to put some of that down in there like that. Now I'm going to turn on this sun lamp. So what's going to happen now?
Well, let me see. Well, the smoke, the cold air from up here is pushing the smoke down in this little hole
Right.
and down into where the little Eskimo is.
Okay.
And there are ice cubes where he's standing.
Right.
So that's going to cool the air where this right over in this section. And it's going to travel up, down here, and over to where the little Hawaiian girl is. And the sun lamp is heating up the air in this section. So as the cold air pushes over from where the little Eskimo is, all the way across here, it's going to push the warm air up.
Now can you see the warm air going up over here?
Yes, you can see the smoke traveling up,
Okay.
and now it's coming out here.
Yeah. So in general, what kind of conclusions can you make as to the movements of the air over the surface of the globe? What is usually happening up at the North and South Pole?
Well, at the North Pole or the South Pole, the cold air is going across.
It's hugging down to the ground and
Yes.
it's probably going down, okay? What about at the equator down here?
Well, here it's very hot because the sun is constantly beating down on it.
So it's probably rising there.
That's right.
Okay, but now how about in the middle over here, where you are, on top of that hill there, see, that's you. What would you say as far as the air is concerned?
Well, I'd be getting a wind. Wind
Yes,
is coming
it'd be
across
awful
this way.
breezy right there, wouldn't it?
Mm-hmm.
Right. Okay. Now, would you go over and get that earth over there on the stick?
Oh, here. Here you are.
Thank you. Because now we saw that at the North and South Pole, the air is moving down and probably hugging the earth. And out here, it's coming out, right?
Yeah.
So we now have convection currents going right around like this.
Oh, I see. So that the cold air comes down here, the warm air is pushed up, and it goes right back again.
Of course, now, this is generally what makes the wind blow in a very general way. But actually, the earth is moving, too, isn't it? See, it's spinning like this. So this means that the air does not go straight down this way, but is begin to be pulled by the earth.
Oh, so it tilts, sort of.
Well, it actually drags the air, so that makes it blow from the west. See, for
Oh,
one
I
thing.
see.
Then, for instance, what if there's a range of mountains across here? The wind would try to get, but couldn't get by
It
them.
would block it.
See, so
The
that would
mountains
block it. So that would make a difference, too. And then perhaps there's a large area of water. This means that the air might get cooled off just by the water, you see. So that while in general, the air is moving from the warm areas to the cold areas over the whole surface of the earth, it's really much more complicated than that. But now, when I ask you what makes the wind blow, what can you say?
Well, when the air over the earth is heated unevenly.
Right. Here, let's take this smoke thing and put it in water, because that stops. Now, you know what makes it rain?
Sure, I know what makes it rain.
Well, good. Then you should be able to explain all the things that are going to happen now, because that's what we're going to do. We're going to make it rain. First of all, see that tin can?
Here, this one.
Okay. Would you put that ice in there?
Okay.
I'm going to add water.
All of it you want me to
Yeah, put all of it in. And while you're putting the ice in, I'm going to add lots of salt.
Salt?
Yeah, now, why do you suppose we're doing all this?
Well, we're making the can very cold.
Right, we're going to make inside of the can very cold, and that gradually is going to take the heat away from the outside of the can. In fact, you probably have never done this, but this is one of the ways that you make it nice and cold, so you make homemade ice cream.
Yep.
But you've never made it this way, I'm sure. You're too young. Okay, now, lots of salt. You want to stir it up just a little bit?
Okay.
Now, do you see anything happening around on the edge of the can yet?
Well, right around here, below here, it's starting to get frosted.
You see how it's getting frosty? You can see moisture there, but none up here.
No,
Why isn't there any up here?
Well, because there isn't any ice up here.
All right, we only filled it up to this point.
That's right.
Where is that moisture coming from?
Well, there's water vapor in the air.
Yes.
And when the warm air cools against the sides of this can, it's going to deposit its water vapor. It's going to go back into droplets again.
You mean to tell me that warm air contains moisture?
Certainly, we just proved it.
Why did this prove it?
Why? Because you could see when the warm air cooled, it hit the sides of the cold can, because it was cold from the ice, and the water vapor condensed.
Okay, in other words, if we have warm air, it probably has moisture in it, and if we can somehow cool off that warm air, we can make the moisture come out.
Right.
Well, that's very good. That's exactly what's happening here.
Oh, I've seen that many times.
Where?
You know, after you take a shower, the mirrors are always fogged up like that, and let me see, where else have I seen that? Oh, on water pitchers in the summertime, you know, like ice-cold lemonade, you see it running down the sides.
Yeah, you probably never noticed it, but some people say that the pipes, the cold water pipes in the basement sweat. Really is they drip water because they're cold, and the warm air in the basement touches them and deposits moisture on. People sometimes think it comes from the pipe, but it doesn't really. Have you ever noticed also when you're out driving on a nice warm summer day and it begins to rain and you have to roll all the windows up?
Yeah, then it starts getting foggy,
It's kind
too.
of foggy on the inside.
Or on a cold day in the house, when it's cold outside and it's warm in the house, all over
Sometimes,
the windows.
yeah. Okay, so the point is, warm air contains moisture. If we can cool it off, we can make the moisture condense on something, can't we?
Right.
Okay, very good. Now you should be able to then explain how we're going to make a cloud.
Cloud?
Now we're going to make a cloud now. In order to do that, here's where we're going to get our water vapor. Now let's let it get cooking here for a minute.
I see.
Okay, where's the water vapor?
The water vapor?
Yeah.
This is the water vapor.
No. Right here, let's stop sputtering for a minute. Right there, you know, where you can't see anything at all?
Yes.
Right at the edge of this, that's steam.
That's steam.
Yes.
Oh.
Some people call it live steam. This means steam at 212 degrees. This is water as a gas, so you can't see it. Okay, now you can begin to see it up here. You see this stuff?
Yes.
What is that?
Water vapor?
No, this is water droplets,
Water droplets.
because you can see it. So steam now condenses into sort of little drops of water. They're not as big as raindrops, so they're called droplets. You see, small. So they're water droplets up here. Now, then up here, you can see it begins to disappear.
Yeah.
What is that stuff up here that you can't see?
Water vapor? Oh, my God.
Water vapor, finally. Remember, you cannot see water vapor any more than you can see the water vapor in the air right here, can you?
Oh, there is some here.
Right, there's some here, and we just condensed it over there. Now, it seems to me if we put that water vapor here in this big dish, and I put some ice on the bottom so it get nice and cold, we should get a cloud, right? Because we'll condense the water vapor.
Yeah, it should work. No, it doesn't.
Doesn't very much, does it?
Well, there's some, but not
There's
very
some
much.
that's condensing here on the side, but nothing much in here. Well, we have to do something else. Here. You want to hold that for a minute?
Okay.
I have my special patented smoke source. You want to hold that for a minute now?
Okay.
There.
Okay.
Now I'm going to put smoke in there. Do you see much of it? Anything?
No, it fades away.
Okay. Now watch. I'm going to put both smoke and some of this water vapor. Watch what happens.
Oh, now there's starting to be a cloud.
Now, you see that cloud?
Now it's really getting smoky and foggy.
Yes.
Well, how come?
Yes, how come? Oh, thank you.
You're welcome.
Why is it that the moisture condensed over in that can? Where did it condense in the first place?
Well, it condensed on the sides of the can.
Right. Where did you begin to see moisture condense here?
On the sides of this
Okay,
thing.
but what's in the middle here? Except now. Smoke. So what do you think that the moisture is condensing on to form droplets?
On the smoke?
Yes,
Oh.
on the smoke. And that's why we can form a cloud.
Oh, I see. And then in the air, there are dust particles.
Yes, that's right. Thank you.
So when the water condenses in the sky, it condenses on little pieces of dust.
Right.
Oh, I
Little
see.
tiny pieces of dust. This is very important for the formation of a cloud. And sometimes in the air, the moisture is ready to condense and forming in little tiny pieces, but not enough because there's not enough drops of dust in there. And they sometimes throw some hunks of dust, in effect, in there.
Oh, like rainmakers.
Like rainmakers, sure, and they call it seeding a cloud. Well, now you know what forms a cloud,
Right.
okay, because we get water vapor to form into water droplets.
On something.
Right, now let's make it rain.
We're going to make it rain in here?
Right here. Let's do like this. Okay, now can you tell me what makes it rain?
In here?
Mm-hmm. Right there. What's this?
Well, that's probably supposed to be the ocean
That's
with
the
the
ocean.
sun beating down on it.
Right, except we're boiling it.
Yeah.
Okay. Now
And-
what's this?
Well, I guess that's supposed to be the clouds. It's kind of funny looking, but...
Well, that's supposed to be the cloud, and you can begin to see the water
yeah,
droplets,
there are
can't you?
droplets forming in there.
Now, what's going to happen is more and more moisture comes from the ocean up here.
Well, the drops will get very heavy.
And they get bigger and bigger. You can see some of them getting quite big. When they get so heavy, what's going to happen?
Well, the gravity is going to pull them down, and there goes one.
There's one back here, fella. Now watch. See if you can see one fall up in here. There goes a big one on the side. You can hear them drop and hit over, can't you?
There are a few going back there,
Yeah.
too.
So we have just made rain. There you
There's
can see
another
another
one.
one dropping down here. We've just made rain right in here. Okay. Okay, now we have another problem. This time I want to see if you can answer this question over here.
Question?
Yeah, question for you. Here. Drawing.
Warmer air, cooler air.
Warmer air, cooler air. Which of these is going to be heavy now? From what have you found is going to be the heaviest?
Well, the cooler air should be heavier because it's denser
Right, it's denser.
and it contracts.
Okay, so now then this is going to be the light air, right?
Light
so would
air.
you write light air and heavy here?
Light
Yeah, and
and
heavy.
heavy. There.
Okay, now if this is heavy, this means that all this air pushing down here is going to put more pressure on the surface of the earth, isn't it?
Right down
While over here, the warm air, being light, is not going to put as much pressure. How do we measure that pressure?
there. With a barometer.
Yes, with a barometer. Have you ever made a barometer?
No.
Oh, well, good. Nice. You can make a barometer very easily. In fact,
Yeah?
well, sure. See that can sitting over there?
This?
Yeah.
Coffee can.
A coffee can, and here is a rubber balloon and a straw and some paste and a rubber band. That's all you need to make a barometer. Here. Take the balloon and put it over the top surface of the coffee can. Then, rubber band around it to make sure that no air can get in or out. What have we got inside?
We've got air in there.
Air in there. Okay. I have rubber cement, but you can use paste. You just put a little on here like this. There you have a barometer.
That's a barometer?
That's a barometer. What's going to happen now if air, heavy air, heavier than when we made this, comes across here and now starts to push down on it?
Well, it'll push down on the balloon.
Push down the balloon. See that? See what happens up here?
The straw goes up.
See how the straw goes up on the other end? Okay. Now, if we put a mark over here, we could then see that it went above the mark. Right? Now, what happens if the air gets less pressure on top here?
Well, if it gets less,
Yeah.
then it'll expand.
It'll like push up, right?
Push up.
And the straw.
We'll go down.
Okay. Now, I've got one all rigged up with a special way for us to change the pressure. Here it is.
It's in an aquarium, too.
Yes. See, now, here's what I've done here. Okay. See that? We'll put this one up here because that one's just like this one down in here. See? Now, let me pull it over here so you can see. Inside this coffee can is what?
Air.
Air captured, okay? So you have the straw, and over here is a little chart. Now, in this particular case, I put a hose on the end of a hole. Now, I don't know. Here, let me get this coffee can out of the way. You see it right down in there?
Oh, I see it.
See, there's a hole in there?
Just a little one.
There's a little hole,
Like a
so
ring.
I can change the amount of air inside here, see?
Mm-hmm.
Okay, now, when I'm going to blow into this hose now and create more pressure over here, what's going to happen to that can?
Well, you're going to create more pressure.
Yeah.
Then it's going to push down on the top of the can and force the straw up.
Okay, what?
There it goes.
See it? Now I'm going to suck air out to lower the pressure in here. What'll happen?
Well, then the straw is going to go down.
Okay.
There it goes.
Yeah? Now, why should we want to know that? Why should we want to know if the air is heavy?
Well,
Here.
there's our chart again.
Let's take this one. Warm air, light. Is it going to have more moisture or less moisture than dry air?
Well, because of our experiments, I'd
Yeah.
say it'd have more moisture.
Okay, so I want you to write moist here.
Moist.
Okay, and how about this one?
Well, then that would be dry.
Okay, you write dry then. Okay, now if the barometer is falling, in other words, it's getting low, that would mean that warm, light, moist air there. If you have warm, moist air and it begins to cool off, what's going to happen to that moisture?
Oh, you might have rain or
Rain
snow.
or clouds or snow or something, right? So that means change. How about if the barometer starts going up because heavy air is coming here?
Well, then it would be nice and fair.
Right.
Because it'd be dry.
And probably cooler.
Mhm.
Right. So you see now how the barometer alone can give you some indication of what kind of conditions are existing in
Just
the air.
by the air pressure.
Just by the air pressure alone. And that's why... See this?
A barometer. A real one.
A real barometer. And this time, they have the things marked off in inches. See, that's actually inches of mercury. Now, can you see what it says? Can you read what the pressure is?
Change.
Yeah, it says
change.
it says
7 inches.
Change. That's 29.7.
Oh, I see.
See? You're just reading the 7 part of it. And it's changed because it is someplace in the near the center. Now, some of these barometers, like this one, just say change, fair, and and so forth. Actually, it is when the barometer is falling
That it says change?
that change is actually taking place. But if it's
If
very
false,
high...
then it might rain.
Yes, if it's very high, notice what it says over there when it's very high.
Very high.
Yeah.
Well, then it'd be
Over here.
they're very dry.
Yeah, and if it's very low...
Well, then it'd be very sunny.
No, low.
Stormy. Oh,
Stormy, that's right, stormy. Okay, well, right now, it probably has changed, so maybe you should be getting on home before the change takes place.
What are you going to do next week?
Well, next week, I'm going to explain to you about the skin on water.
Skin on water?
Hey, didn't you know water had skin on it?
No.
Well, it's not really skin, but it acts an awful lot like it. Back here, watch. Would you pour that water into that pan?
Okay. Skin on water?
Yes, skin on water. Now, here's one way of showing you, because if you take this match and put some of this special stuff on the back and throw it onto the top surface of water, watch.
It's swimming.
Yes, and that's caused by that invisible skin, which you'll find out about next week when we investigate surface tension.
Be sure to be with us next week when Mr. Wizard and Eddie investigate surface tension. Watch Mr. Wizard was presented by the Public Affairs Department of the NBC Television Network in cooperation with New York University.